Hey all dear students, let's see this classic chasing problem of relative motion with a little bit of twist. So as you can see here, you can see there is a equilateral triangle, and the vertices of the equilateral triangle, three particles A and B are situated, and they are told some instruction. It is told to A that you have to chase to B always. Your velocity will always be directed towards B, and to B it is told that your velocity will always be directed towards C, and same thing has told to C that your velocity will always be directed towards A, and they have to move with the same constant speed v. So the first question is how long it will take, whether they will collide or not, and if they will collide, where they will collide, and what will be the time of collision right starting from right now. And most of the books teach this using the concept of velocity approach. We'll go a step further and we'll also try to derive the equation of trajectory of either particle using the polar coordinates method. So let's go ahead. Before we go ahead, I'll give you a little bit introduction of the concept of velocity approach. So as the name says, velocity of approach, the rate at which the separation between the two particles decreases. So suppose the velocity of approach between two particles is 5 meter per second. What does that mean? That their separation is decreasing by 5 meter in every 1 second. And suppose it is given that they collide, and suppose initial separation was say 100 meter and the velocity approach is 5 meter per second. So in every 1 second separation is decreasing by 5 meter, and initial separation is 100 meter, and when they will collide separation will become 0. So obviously they will collide in 20 seconds. So if it is certain that the particles are going to collide and velocity approach is constant, so we can say that the time of collision is equal to initial separation upon velocity of approach. That is one thing. And then to calculate velocity of approach, we have a relative motion concept. So suppose two particles are moving something like this, and we have to find the velocity of approach at a certain moment. Like this, I can take a general situation. Suppose this is A and this is B. The velocity of A is say VA and velocity of B is say VB, and they are making angle theta A and theta B with the line joining them. So what is the velocity of separation between them at the shown moment? So for the particles to come closer, it is the component of velocity along the line joining them are responsible. The components of the velocity perpendicular to line joining are responsible for their relative rotation. So what we have to do, we have to make a components of velocity along line joining them. So suppose if I make a component of VA along this line, that is a VA cos theta A, and this component I am not bothered about. Same way, this component of velocity is a VB cos theta B, and this component I am not bothered about. So velocity of separation between them is the rate at which one particle, or the velocity with which one particle approaches the other along line joining them. So if I sit at A and observe B, and I just want to ask with what velocity B is coming towards me, that would be the velocity approach. So in the frame of A, if we look, so it will give its velocity to be in the opposite direction. So here in this case, the velocity approach would be how much? VA cos theta A plus VB cos theta B. So here we will first of all find the whether the particles are going to collide or not. And if they collide, obviously it is the symmetry of the problem tells that they will collide at the center of mass. So now suppose everything is symmetric, so I can take any two particles. Suppose I take particle B and particle C. Initial separation, initial moment. So velocity of B is like this along the line joining them, and velocity of C is along this direction towards A. And this angle is 60 degree because it is an equilateral triangle. So velocity of approach between them is the component of the velocity along line joining them, it will have the full component v, and this will have a component v by 2, v cos 60, v by 2. This component we don't bother. So with respect to this, the c is coming towards b with velocity v plus v by 2. So velocity approach at the initial moment is 3v by 2. So let me write it here. So initial moment velocity of approach is 3v by 2. Now let's see situation after a little while. After a little time, A reaches somewhere here, B reaches somewhere here, C reaches somewhere. The instruction given to them was A, you have to always move towards B. B, you have to always move towards C, and C, you have to always move towards A. So they will continuously update their direction. Now, after a very little time, when A comes here and B comes here, C comes here, so now the line joining A and B would be this, and line joining B and C would be this, and line joining C and A would be this, like this. And the new velocities would be like, no, this would be, no, the velocity of A would be towards B, velocity of B would be towards C, and velocity of C would be towards A. So because these distances are equal, traveled in equal time, so the new dotted triangle is also equilateral triangle. Same way, after a little later, A reaches here, B reaches here, C reaches here. They are continuously updating their direction. So now the triangle joining them would be like this, like this, like this, like this, like this. And now this direction would be like this direction would be like this direction would be like this. At any time, you can see at any time the line joining, the triangle joining these three points is a equilateral triangle. Only thing that is happening, the size of triangle is shrinking, and where it will become a point that should be the center of the centroid of this triangle. So basically they are coming closer and the side of the triangle is becoming smaller. So at any moment, this was the picture at the initial moment where the velocity approach was v plus v cos 60, that was 3v by 2. At any later moment, the shape joining them is still equilateral. So if I say this is 60, this is 60, so between any two, velocity approach would be this is v, so v plus v by 2 is 3v by 2. So I can say that the velocity approach 3v by 2 is a constant, and the approaching separation becoming decreasing, separation becoming smaller, and it is clear that they have to collide. And in the beginning I told that if the particles are going to collide and v approach is constant, so time of collision is the initial separation divided by the velocity of approach. And obviously if they will collide simultaneously, because same thing is for the same picture is for all of the three. So I am calculating time of collision between B and C. So initial separation was A, and velocity of approach is how much? 3v by 2. So my time of collision would be 2a by 3v. So that's, and they will move like this, they will move like this, they will move like this, it will move like this, like this, like this, like this, like this, and the separation is becoming smaller, and they will eventually collide at the center of this triangle, or the centroid of the triangle. Now our main question is that we want to find the equation of trajectory of either path. I will take the suitable reference line, so along which path one of the particle is moving. So for that, let me draw a new diagram. And for finding equation of trajectory of either particle, we'll use the concept of the polar coordinates, plane polar coordinates. So let me quickly explain what I'm going to do. Normally, we use the Cartesian coordinates. Suppose I want to use the polar coordinates. Suppose this is my normal Cartesian coordinates. And in Cartesian coordinate, particle is moving in this plane. Suppose particle is moving something like this, It is moving like this. And if it is somewhere here, so in place of defining this position as a x comma y, I will define this position as a r comma theta, where r is the distance from the origin. So that is r, and theta is angular position from a reference line. And suppose if I take the reference line as the x-axis itself, so that is a reference line theta. In polar coordinates is x comma y, and in Cartesian coordinates are x and y, and the same thing I'm writing in the polar coordinates. So this is the increasing direction of r. So we can put a unit vector in the direction of r as a r cap. And if we take a basis of unit vector, the basis unit vector should be mutually perpendicular. Otherwise, they will be dependent. So basis vectors have to be independent. So if one unit vector I am taking along this direction, so other has to be perpendicular to this. And the other unit vector is theta cap, and that is in the increasing direction of theta. So that is a theta cap. Velocity is always tangential to the path. Suppose particle is moving like this, and at this moment particle was moving like this, and this moment suppose velocity is this v. So this velocity has a two components. One component is along the r cap direction, and one component is along this direction. So this we write vr, and this we write v theta. So you can see that if there is VR, so it means R is increasing. If R is not, it can decrease also. So basically VR is the rate of change of R. Velocity along radial direction is dr by dt. And velocity along, this is not the tangential direction, this is tangential direction, is this along velocity. So velocity along theta cap direction. So if we look from here, and suppose the particle always moves like this, that would be the circular motion. In the circular motion, velocity is r omega. So if it is always moving with the r radius, it is always at a distance r from the center. So it is moving in a circle, and in circular motion we know that velocity is r omega. So this velocity is actually r omega. So that velocity we write v theta. So v theta is equal to r omega. In place of omega, I can write r d theta. In place of omega, I'm writing d theta by dt. So let me just rub this thing and leave the useful thing. So I want to find the equation of trajectory of this particle in polar coordinates. For that, I have taken the reference line this, and the origin of the reference line is at the centroid where the particle is going to meet. So paths we discussed, this is going to move something like this, like this, like this, like this, and after many turns, or maybe infinite turns, it comes up to here. So that is this path. Suppose initially it started from here. So the distance from the initial position, if I write, suppose this is the r naught. Initially particle is at here, and this is at t is equal to 0. So this r naught from where it is started is the distance from the center to either vertex, and that would be how much? A by root 3. R naught is A by root 3. Now suppose after some time particle reaches somewhere here. Particle reaches somewhere here like this. Particle is rotated by angle theta. This angle is theta, and this separation, this is a general separation. Particle is here, and this general separation is smaller. And now the velocity here is, this velocity is, speed is always v. So its velocity is along this direction, speed v. I want to state one more thing here. The way we derive the time of collision. Now look in another way. We can approach the problem in another way. A, B, C were the three particles initially at the vertices. Eventual collision is going to be at the centroid of the system. So I don't want to see the collision of B and C. I know that the particle is eventually going to reach here simultaneously. So basically the target of B is here, right? Target of B is to eventually reach to the center, that is O. At the initial moment, the velocity is this V. So on this line, this is the final target and it has to collide with this. So and this is at rest. So line joining OB is making angle 30 degree with the velocity. So velocity of approach between O and B is equal to how much? Simply V cos 30. V cos 30 mean V root 3 by 2. And it has to collide. So obviously the velocity approach has to be constant. So at any future moment, suppose this particle goes here. So if I make this new line, suppose it is here. So if the velocity approach has to be constant, so now this velocity will will make a still angle 30 degree with the line joining center to this particle. Only then it is going to collide at O. So using that thing also I can find the time of collision. So this initial separation was how much? This was A by root 3 and the velocity approach is constant. So time of collision will be the initial separation A by root 3 divided by V root 3 by 2. So again we get 2A by 3V by another method. This thing I am going to apply here. So what I told you that velocity vector will always make an angle 30 degree from line joining center to that particle with velocity. So here after some time, suppose it has come here, so this angle is still 30 degree. So now making component of V, this is the my radial direction. Just the way I explained, radial direction is the direction from the center to the particle in the radial away direction. So this is my radial direction, and this direction is perpendicular to radial direction in the increasing direction of theta. So the two components of the V, one component is this and one component is this. This component is V sine 30, V by 2, and this component towards the origin, that is how much? V root 3 by 2. Now we will use this thing. So VR, this is the VR part, but because it is towards center, so we will write minus. So VR is basically dr by dt, and how much is this? This is minus V root 3 by 2. And this component is a r omega or r d theta by dt, and this is theta. It has already rotated by this angle. This angle is theta. So V theta is equal to r d theta by dt. And how much is this? Is positive direction. This is V by 2. So just divide these two equations. So if we divide these two equations, we will get 1 by r dr by d theta. dt dt will get cancelled, and from here we'll get only root 3. So we've got the simple differential equation r and theta. So dr by r is equal to minus root 3 d theta, and integrate it when it started, because I'm measuring theta from this reference line. Initially the theta was 0, r was r naught. So at theta is equal to 0, r is r naught, and r naught is how much? Let me write r naught right now. R is r naught, and when it has rotated angle theta, so r has become r. So this is a simple integration that will become ln r by r naught, and this is minus root 3 theta. So r is r naught e की power minus root 3 theta, and the value of r naught is a by root 3. So a by root 3 e power minus root 3 theta. This is equation of an equiangular spiral. So the particle is going towards centroid continuously. The radius, the minus sign tells the radius decreases. So it will take a lot of turn before arriving to this, and the radius will decreasing. It will follow this path. Same path will be followed by this particle, but here for that thing we will have to take this reference and angle from here theta. So similarly for here. So we've got the equation of trajectory also, and using this equation of trajectory we can find few more things. If it is asked, you can simply immediately tell how much time it has taken to collide. The time taken is this. Total distance is the v into this. But if it is asked how much distance the particle has traveled in the one revolution. So in one revolution mean the it has rotated by angle 2 pi. Started from here, so the one revolution will go like this, like this, like this, like this, like this, and up to here. So here this one revolution will be there. So now that we have got the expression for r versus theta, and using this equation you can find time taken from here to here, and once you get time you can also find a distance. So many other things can also be done once we get the equation of trajectory. Thank you for watching. Stay tuned for such very good questions.